Alright, in this session I want to talk about the I's and J's used together with a G2 and a G3 arc commands. So far we've learned that anytime we do a clockwise or a counterclockwise arc, that on that line we need to put an R value, and that represents the radius that the center of the tool swings around the radius that it produces. So what I've done is put two programs side by side. And the reason why we have to go over this is because you're going to walk up to a machine. Some machines use the R, some machines use the I's and J's, and it all depends on who wrote the program, what software was used, if it was handwritten, if it was posted out by a CAD system. You're going to need to understand what the I's and J's mean. So let's look at the program here on the left, where when we come to our counterclockwise radius here, we are using a G3 and the part radius is 750. The tool diameter is a ½ inch, so the radius is offset by a ¼ inch, so the tool is actually swinging a ½ inch radius, so hence the R.5. Okay, now that same line is used in the program on the right side. You can see it's still a G3, it still has the same endpoint in X and Y, but instead of an R value we have an I.5 and J0. Okay, so what does the I mean and what does the J mean? Alright, so what I've done is I've dimensioned the distance from the center line of the tool to the center point of the arc. And we know that that is a ½ inch radius because we used that here on the left side of the program. So that is the incremental distance in X. So if you think of I being X and J being the Y incremental distance to a radius. Okay, so what the machine needs to know on this G3 line is, first of all, the G3 determines that the tool is going to move in a counterclockwise arc from where it's at to a point, X and Y. In this case, X to 3 inches 750, Y minus 750. Okay, then I.5, it wants to know where the center point of the radius is in relation to the tool in an incremental distance, meaning the distance away measured from the tool to the radius. So we know that that is a ½ inch, but it is a ½ inch in the plus direction. Notice we're coming from the center of the tool to the center point of the radius in a plus direction, and therefore the I is a 0.5. J is the distance in the Y direction, and since we are perfectly in line with the center line of the radius, in this case Y is 0. Okay, so that's how the I's and J's are used. I represents the incremental distance in X from the center of the tool to the radius, and J is the Y distance from the center of the tool measured to the center of the radius. Alright, let's take a look at the G2. And you can see the tool is tangent, getting ready to swing an arc. The part radius is 750. Again, we're offset, so the radius we're swinging is 1 inch. Okay, so G2 with an endpoint of X minus 0.250, that's where it ends right here. Y minus 2 inches 250, and we swing a radius of 1 inch. So in the program on the right, the G2 and X minus 0.250, Y minus 2 inches 250 are the same. So we just learned that I is the distance in X incrementally from the center of the tool to the center of the radius. Well, X would be left and right, and we're right in line with the center point of that radius, so that would be a 0. Okay, now let's look at the distance in Y. It says J 1 inch. Why? Because the distance from the center line of the tool to the center line of the radius, measured from the center of the tool, is 1 inch in the plus direction. Therefore J is a plus 1 inch. So the main thing I want you to take away here is that the I represents the X value and the J represents the Y value. Okay, and that the I's and J's are measured at the start point of the radius. So at the start of that radius is when the machine needs to know what is the distance from where I'm at, from where the tool center line is, to the center line of that radius. And that's what you tell the machine so it knows how to swing that arc.